Good morning, friends. I'm Dr. Shivani Jain. I did my MBBS from Government Medical College, Meerut, post-graduation from UCMS, Delhi, and I did my senior residency from the same college. Now I'm in private practice and has been teaching for last 6 years. Topic of today's discussion is lens and cataract. Guys, this is a very important topic because a large number of MCQs comes from this topic. Important not for only you but for me also, because it is the breadwinner for us ophthalmologists. Guys, apart from all these stuff, cataract has laid the foundation of modern ophthalmology. Cataract is the main leading cause of blindness globally. So with all these basics in mind, let us start with our topic of today, lens and cataract. So guys, first we will go through the basic things about lens, its anatomy, physiology, and then we will start reading about the pathologies. So we all know that lens is a transparent structure which is also avascular. Now guys, why lens remains avascular? If you remember day 1, topic number 1, anatomy and embryology, we learned that during embryogenesis, this is the developing eyeball, cornea, the optic disc, and this is the developing lens. If we remember that there was a canal which was running from the optic disc to the back of the lens. This hyaloid canal has a central vessel which is hyaloid artery. So this hyaloid artery, this canal, it regresses at birth. This only is present during embryogenesis, giving nourishment to the developing eye. That is why the lens remains avascular after birth. So this is the reason you must remember why lens is avascular. Apart from them, other things about lenses, that lens is a biconvex structure. It is a biconvex structure. It is not an absolute spheroid. It is but a spheroidal structure, not a perfect spheroid but a spheroidal structure. So if I talk about the shape of the lens and the parts of the lens, this thing on the top and the bottom, we call it equator. So this is the equator of the lens, and these two, the anterior and posterior, these two are called as the poles of the lens, isn't it? Now please understand this. Guys, lens is a structure like this. So it has been suspended by zonules on 360 degrees. So this whole thing is the equator of the lens. Okay, so equator is 360 degrees on the lens, held by the zonules. Now guys, we will talk about the refractive indices. So let us understand what refractive indices are. Guys, I hope you understand that the main job of eyeball is vision, and this occurs because of the refraction. So eyeball has got various refractile surfaces, starting from the tear film, the anterior part of the cornea, the posterior part of the cornea, the aqueous humor, anterior surface of the lens, the central part of the lens, the posterior part of the lens, again aqueous humor, then we have vitreous humor, and finally light rays reaches to the retina where the image is being formed. So all of them have a particular refractive index. So we have to learn what are the different refractive index, and it is very easy to remember. Let us start. How can we learn them? So the refractive index of the liquids, which are aqueous humor and the vitreous humor, is very simple, 1.34, the least of all. Now next is the cornea. So the refractive index of cornea will be little more as compared to the aqueous and vitreous. It is 1.37. Now next one is the refractive index of lens. So this one is, of course, would be higher because lens is more sclerosed. So it is 1.39. Now a new question came few years back. They has asked you, what about the refractive index of central part of the lens? So the central part of the lens, guys, it is supposed to be more dense, more sclerosed. That is why the central part of the lens has a higher refractive index, which is 1.42, and this is very important question. So central part of lens has a refractive index of 1.42. So you must remember all the refractive indices. Now let's talk about the refractive contribution, the refractive power of the structures. Now we all know that the refractive power of the eyeball as a whole is plus 60 diopters. Why a plus? Because the eyeball is going to converge all light rays. That is why we always give a plus sign, okay? So plus 60 diopters is the total refractive power of the eyeball. Now from this plus 60, most contribution is by the cornea. So plus 45 is contributed by the cornea. Now the remaining 15 or maybe 16 diopters is contributed by the lens. We can say plus 15 to plus 16 diopter is contributed by the lens. Vitreous humor, aqueous humor plays a very little role, so we hardly mention them. So cornea and lens are the major contributors. So lens gives a refractive power of plus 15 to plus 16 diopters, and this has been invariably asked in various examinations. Now after that, few basic things. Let us learn in detail about the anatomy of lens, which is here. So guys, if I draw the lens something like this, it is not a proper biconvex shape. The anterior surface of lens is rather little flat as compared to the posterior surface, and posterior surface is rather more convex as compared to the anterior. Now the radius of curvature of anterior and posterior surface are different. That is the way. So what is the radius of curvature of the anterior surface? So the anterior surface has a radius of curvature which is approximately 10 mm. And similarly, the radius of curvature of posterior surface is 6 mm. So guys, what does this mean? Let us understand. Friends, if I make a circle taking posterior surface of the lens as a part of the sphere, something like this, if I make a sphere taking posterior part of the surface of the lens as one of the refractal surface, this would be 6. This would be 6 mm. Similarly, if I draw a sphere whose a part of this sphere is the anterior surface of the lens, the radius of curvature here would be approximately 10 mm. So this is the meaning of 6 mm and 10 mm. You must remember that, the radius of curvature. Now next question is, what is the equatorial diameter of the lens? So equatorial diameter is something which is the diameter of equator to equator. So this is your equatorial diameter, and this amounts to be 10 mm. Again a question, very frequently asked, equatorial diameter. Now next we will talk about the thickness of the lens. Now guys, you will be surprised to know that lens is the only structure which continues to grow throughout the life. Lens increase in girth, so the width of the lens increases at various ages. So in neonates, lens has a thickness of just 3.5 mm, and it increases in thickness by 0.02 mm per year. So it increases in thickness. So in me, it might be approximately 4 mm. In my parents, it might be like 4.5 mm. So you must remember, in old age, the lens grows in thickness and it reaches to up to 4.5 mm. This is important. Now, if I go with the structure of lens, I would see that lens on the outermost surface has a capsule. So we have a beautiful capsule on the outer surface of lens, which has some special things in it. We will discuss it in a short while. On the outermost surface, we have a capsule of the lens. Now, if we talk about the inner side, we have the epithelium. Something like this is the epithelium of the lens. Now, inside the epithelium, we have lens fibers, which are the cortical fibers. We call it cortical fibers, cortex or cortical fibers. Now, inside the cortex, we have a zone which we call it the nucleus. So, the central zone is the zone of the nucleus. So, this is about the basic anatomy. On the outermost side, we have a capsule. Then we have epithelium. Inside that, we have cortical fibers. And the centralmost part is the nucleus. Okay. Now, let us discuss in detail about each of them. So, first thing we have to talk about is the capsule of the lens. So, we have a capsule of the lens. Now, guys, mind you, the lens capsule is very, very thin. It's very beautiful. It's a beautiful capsule. The capsule is very thin. But the important point about this thickness is the capsule is that it has the thickest basement membrane in the body. So, it has the thickest basement membrane in the body. Important. Now, this lens capsule contains type 4 collagen. Again, important. It has type 4 collagen. Lens capsule otherwise is very, very, very elastic. So, this lens capsule is very elastic. But surprisingly, there is no elastin tissue here. Surprisingly, it lacks any elastin. There is no elastin. Okay. So, these are the main points about capsule. Now, they have asked us about the thickness of the capsule. Where is the capsule thinnest? Where is the capsule thickest? So, the capsule is thinnest at the posterior pole. Capsule is thinnest at the posterior pole. So many times they have asked us, where is the capsule thinnest? Now, they can also ask us, where is the capsule thickest? And thickest is at the posterior pre-equatorial region. Posterior pre-equatorial region. So, if I draw the capsule and the lens, let us see how it will look like. So, that's the biconvex lens. We have a capsule on the outermost side. That is the posterior pole. That's your anterior pole. So, I told you that capsule is thinnest at the posterior pole and the thickness of the capsule at the posterior pole is approximately 4 microns. That you have to remember. Now, capsule is thickest in the posterior pre-equatorial region. Somewhat here is the capsule thickest. So, this is posterior pre-equatorial region. And they can also ask you what about the thickness. So, it is approximately 23 microns. This is the thickness at the posterior pre-equatorial region. Now, we discussed that inside the capsule we have a layer of epithelium. So, now let us discuss something about the epithelium. We have epithelium. Now, guys, please see and understand this. During embryogenesis, lens is absolutely spherical. Now, during embryogenesis, we only have an anterior and posterior epithelium looking like this. So, what happens when this lens starts growing? It doesn't have any fibers. So, the lens fibers will be produced by the elongated posterior epithelial cells. The posterior epithelial cell starts elongated and they produce future lens fibers, something like that. So, these are the elongated posterior lens fibers. Now, guys, when these posterior epithelial cells are used up, they will not be seen in adult lens. So, all of us, we don't have any posterior epithelium in our lens because they have been used up in formation of the lens fibers. Now, whatever lens fibers are formed from the elongated posterior epithelial cells, we call them the primary lens fibers. We call them the primary lens fibers. So, this one which I am shading in pink is our primary lens fibers which are formed by the elongated posterior epithelial cells. Another name of these primary lens fibers are embryonic nucleus. This is also called as the embryonic nucleus. Now again our anterior epithelium remains here, the posterior epithelium is lost. Now guys, let us see how more lens fibers are added to this lens. So if I go back to my picture, this is the anterior epithelium, this is my anterior epithelium, and look at the way I'm drawing the cells of the anterior epithelium. I hope you understand the central cells I'm drawing, they are cuboidal in shape, isn't it? And the peripheral cells, the pre-equatorial cells, they are almost columnar in shape. So these cells are columnar in shape, the central cells are almost cuboidal in shape. They are almost cuboidal in shape. So what is the basic fact here? Why they are columnar? These cells on the pre-equatorial region, the columnar cells, they have a mitotic potential. They continue to produce cells throughout the life. That is why this is the source of the lens fibers which come into the lens, and that's why the lens increase in girth. Okay, so this is the source. The columnar cells, this is the source. They have a mitotic potential and they continue to produce the lens fibers. This is the important point. Continue to produce lens fibers. So all those fibers which will be added upon by the pre-equatorial cells on the anterior capsule will now be called as secondary lens fibers. Now let us see what will be the arrangement. We all have a central embryonic nucleus here which has been formed. So this pink part is your embryonic nucleus. Now all those fibers which will be added upon, I told you, will be called as the secondary lens fibers. Now an important thing before we understand how these are arranged, let us understand through this picture. Now we have Y-shaped sutures. One Y is here on the anterior surface, erect Y. One Y is there on the posterior part of the embryonic nucleus, which is an inverted Y. So this Y is nothing but the shape of the sutures. This is basically the configuration how more lens fibers will be added upon. So this Y, two Ys, they are nothing but the sutures. This is nothing but the Y-shaped sutures. This is showing the configuration of how the lens fibers are going to be attached. Configuration of lens fibers attachment. So invariably a question has been asked, which zone of nucleus, which zone of lens has those Y-shaped sutures? So Y-shaped sutures are present in fetal nucleus. A very important question. Now let us understand what fetal nucleus is exactly. So guys, we have the embryonic nucleus. I told you the primary lens fibers are going to form by those posterior epithelial lens fibers. So this one is our embryonic nucleus. All those fibers which are being formed from 0 to 3rd month of gestation are going to be included in this embryonic nucleus. Now outside this embryonic zone, I told you we have Y-shaped sutures, anterior erect Y, the posterior inverted Y. Now the fibers which are being laid down outside embryonic zone, and that too from 3rd month onwards till birth, these are going to be included in this fetal nucleus, and we call this zone of nucleus to be the fetal zone, the fetal nucleus. Now all those fibers which would be laid down after birth would be called as the infantile zone of the nucleus. So I am shading this in blue color. These are the fibers which will be laid down after birth. So this zone of the nucleus would be called as the infantile zone. Infantile nucleus. So we can say it that this is laid down after the birth. Now guys, after birth till puberty, all those fibers would be included in the infantile nucleus. After puberty, all those fibers which are being added upon would be included in your adult zone. So this zone which I am again shading in your red color, this would be called as the adult zone. Okay. So this is our adult nucleus. Very important point to understand that this is after puberty. Now friends, still we are developing lens fibers, still we are having increase in the girth of the lens. So all those fibers now will be included here and they will be producing cortical fibers. So this will be called as the cortex. Okay, this is your cortex, cortical zone. Now outside cortical zone, again revising, we have the epithelium, posterior epithelium is absent, and just outermost side we have a capsule. So let us quickly revise our topic of the detailed anatomy of lens through these pictures. Let's go back and revise. So on the outermost side we have a capsule which is very thin, highly elastic, type 4 collagen, thinnest at posterior pole, thickest at posterior preequatorial region, posterior preequatorial region, posterior pole. Inside the capsule we have a layer of anterior epithelial, the central cuboidal cells and the peripheral columnar cells. Posterior epithelium is absent here because they are being used up. Inside them we have cortical lens fibers, and if I magnify my nucleus again, the central part will be the embryonic zone. Outside it will be the fetal zone, which is being produced after 3 months till the birth. Outside the fetal zone we have infantile nucleus, which has fibers from birth till puberty. Outside this we have an adult zone. These are the fibers which are laid down after the puberty. So that's about the detailed anatomy of lens. You must understand this very well.